Welcome to Lesson 3 of Module 6 Genetic Change. In this video, we're going to be focusing on biotechnology, and we're going to be looking at how the different social and ethical implications and uses of biotechnology and how this might change Earth's biodiversity into the future. When we talk about biotechnology, we're talking about using biological processes and organisms to create new products and develop new technologies. Gene technology allows us to manipulate DNA to create products for human use. When we genetically engineer something, we're using techniques that are able to manipulate DNA to meet the needs of our society, the environment, and science in a very precise way. When we talk about hybrid vigor, we're talking about stronger, healthier offspring rather than inbreeding. DNA technology are specialized biological tools used to modify, measure, manipulate, and manufacture DNA. And when we talk about gene therapy, it's delivering normal genes that function correctly to individuals who are lacking a functional copy. Sometimes biotechnology is referred to in colors, and we can see each of these colors represent a different section of or use of biotechnology. So we don't need to know all of these colors, but just they sometimes might refer to these colors in some of your readings that you might have. So in ancient times, biotechnology was still used. We saw it in selective breeding, where we saw mules being bred even though they weren't fertile. They were being able to use to transport heavy loads, and this was back in ancient times. And we saw even using fermentation to break down sugars. Where we used to make bread, wine, and cheese. Obviously, we still do, but that's a very ancient practice, and these were built on the manipulating biological processes for the use of humans. In the modern times, biotechnology has improved greatly since the discovery of DNA in 1940, and this is when we say modern biotechnology was started. Modern biotechnology includes pasteurization, agricultural techniques, and these all improve crop yield. It also includes molecular techniques such as PCR and DNA sequencing, and we can use these for DNA profiling, gene cloning, creating genetically modified organisms, gene therapy, and then recombinant DNA, which we'll look at in some future videos. We also know now that we can splice DNA, so cut out genes using restriction enzymes, which is quite a natural process, and these are used to chop up viruses when they try and invade cells. We can amplify DNA through copying them in PCR, and then we can create recombinant DNA by pasting genes with DNA ligase enzymes. Socially, there are quite a few implications of using a range of biotechnology and the techniques that come with them. So this can influence and be influenced by the values of a society, and also change the demographic and economic conditions which the society is in if they use biotechnology. Due to it being quite expensive and requiring a large amount of education to use these, it's widely used by people who have greater access to these, but it has also allowed more people to access these in a range of ways, including safer vaccines being used. Socially, we can also improve the nutrition and yield of our crops grown by our farmers. An example which we'll look at in class is golden rice. However, like I said before, they're not equally accessible to all communities, creating some social inequality, and there's also some privacy issues which come with it, especially when we're talking about DNA profiling and genetic screening. We also don't know how safe genetically modified foods are, and are not current. Some of them are not currently approved for human consumption. We don't currently know how genetically modified foods will affect the DNA of the people who consume it, but we have a large number of regulators in Australia that regulate our use and how we can use them and consume them. In general, society is more accepting of any biotechnology that relates to human health, but more opposed to anything that relates to agriculture and industry. So people don't, and they embrace the genetic testing for the 2 genes that cause breast cancer. However, the production of genetically modified crops can still be opposed by a lot of people. Here we have an ethical matrix, and when we talk about the ethics and aims of biotechnology, we need to look at whether they have a benefit and non-harming, or whether they improve someone's well-being, individuals and rights and autonomy. So that's where we look at choice, we look at respect, and then we look at fairness. So the fact that biotechnology can improve the life of humans and their health and well-being is much embraced by lots of philosophies and cultures. However, for some, it's seen as overstepping a boundary that, for some people, is rooted in religious and philosophical cultures. Sometimes these require really significant views and a lot of debate, especially with issues such as genetic screening and reproductive decisions. And then we also have the idea of dignity, integrity, and a choice arising with these issues. And then for some cultures, even the idea if you could consume transgenic or genetically modified organisms, for some cultures, this would not be acceptable. If we are using any of biotechnology and any of these in health sector, there are a lot of consent forms in place to make sure that the consumer is well and patients are well informed. There's also a lot of legislation, especially around human cloning and how we research on embryos. The fact that we can use DNA profiling in forensic and legal cases for some people is quite an ethical issue. And then when we look at animal welfare, for some, it has been significantly improved, but also for some, it's been significantly impacted on the life of these organisms. In the future, there is definitely going to be new discoveries and advances in biotechnology. And currently, the biggest biotechnological advancement is the CRISPR technique. And this is a genome editing technique, and CRISPR stands for clustered regularly interspaced short palindromic repeats. And we found these enzymes kind of like restriction enzymes. They chopped up the DNA of invading viruses. But now, because we can splice genes with pinpoint accuracy, we can use this technique in health and medicine, but it also raises issues with editing germline cells and the creation of designer babies. We're also going to see in the future stem cells, nanomedicine, and new drug delivery systems, and this is all due to our research in these areas of how we can improve human health by using what's around us as we further investigate, specifically stem cells, how we can use these to replace diseased tissue with new and healthy tissues, and how we can improve the treatment for patients with cancers and different diseases. If we do use this technology, there are going to be changes to the Earth's biodiversity, and because this is artificially altering the path of evolution. It can be used to save species that are on the brink of extinction and therefore improve biodiversity. However, when we selectively breed, clone, and genetically engineer organisms, we do have the potential to reduce genetic diversity in the long term and then therefore increase the risk of populations being affected if there is an environmental change or the introduction of a new disease. We also see genetically modified plants affecting organisms in an ecosystem as they're introduced, and therefore we don't know how they're going to interact with the organisms that are already in an ecosystem and how they'll interact with humans who consume them. But we can use these techniques as a de-extinction technique, and therefore return some keystone species to some ecosystems. That concludes lesson 3. Make sure you tune in for lesson 4.